Hello everyone. My name is Richard Darst. I work at Aalto University as a data agent and a research software engineer in a team called Aalto Scientific Computing. So today's talk combines these two different aspects. So the data agents, which are focused on supporting best practices of data and open science, so basically how people work, and the research software engineer side is about the software and data, like the technical tools of these things. So when thinking about what kind of talks I could give, I know many people who are sort of just starting a new research group. So these people may have, they've probably done computational science before, or maybe not, but you're at a point where now doing the work yourself is not necessarily your main task. Instead, what you need to do is you need to be able to advise the other people for what are the best practices to use and sort of keep things organized. So I have a little bit more about this in my talk itself. So maybe I will share the screen and begin there. So let's say you're a new group leader and you want to make the most of your group's work. So your people will be coming in and know the basic of science. But as we've seen over and over again, you might not know how to use these computational tools in order to produce the best open science and reproducible outcomes. And this is a big problem. So the expected audience for this talk might be someone who's planning a research group using computing. Maybe computing isn't your main focus. In fact, I'm assuming it's sort of not your main focus. Otherwise, you might not be here. So you might have done a little bit, but you know that you'll be hiring people that are doing more computing than you're doing. And you need to mentor these people. So if you haven't done it yourself, if it's not your focus, how do you mentor them? What do you recommend them to do so that people don't go and create a bunch of stuff, which ends up being basically unusable for you somehow? So in the end, the question is, do you want your research to be reproducible or open, or sort of held together with duct tape and wire? And we'll be talking about the things that you should be planning in advance and talking about in order to get this. So why are we planning in advance? So your group's work is valuable. And a typical research group has all members change every 5 years or so. And unless you work hard at things, that means all your knowledge is lost every 5 years. And then if one of your students now is making some really useful method, is someone in 5 years going to be able to use it? Or will the start of their PhD basically be writing it again because they can't understand or maybe not even find what the previous person has done? And this happens over and over so many times. So what are the things that goes wrong that we really want to avoid? Well, like I mentioned, there's starting the project over from scratch. So a new person comes in, you give them some suggestions, say, okay, please do what this paper did. You're going to be extending it. So they spend their first months redoing it all and wasting all the other time in bug fixes that someone else has put into doing it before, if they've been in your same group. That's not great. So often what happens is one of your group members leaves and their previous work is no longer really usable. Because even if someone can find the code, it might not be documented or reusable, or, they just can't figure out how to work it. And then let's say people didn't change and these things weren't problems. But over time, you get more and more code and data and all these things until it's so disorganized, it's unusable. And then you can't do new good work in the future. At the individual level, if people don't have good mentoring, you have problems like you've worked on different problems, like bugs in the code analysis, and people keep solving the same ones over and over again. Or this is one of my favorite things to complain about. Someone does great work, submits it for publication, and then a few months later, the reviews come back and say, please add this extra thing to this figure. But you can't figure out how you got that figure anymore. Like if someone literally can't make the same figure a few months later that they had for a paper, then this is, well, what does this even mean for science? And well, if code is bad, people want to keep it hidden because it's still messy, which promotes all the above cycles to continue. So what's the first step as a group leader that you have to pay attention to? You have to decide how you work together. So one thing I realized, especially during the remote work time, some people in a group are only bound together by having the same supervisor. But basically everyone's doing different projects, starting everything from scratch. You might be talking about scientific ideas or so on, but when it comes to actually doing something, you don't have the tools to work together. This is not good. So you need to decide, are you sort of a loosely coupled scientific discussion group, or are you people who have a shared mission and shared tools to accomplish that mission? So my suggestion here is to not be only results oriented in your group activities. In your group seminars and so on, don't just ask to see results like get published in papers, but actually talk about how did you get these results? Like, did you find the data okay? Was the documentation good? Okay, what code did you make? Where did you put it? Is it documented? Can you show me how to use it on my own thing? These kinds of things will connect your group together and make a thing for the future. And if your expertise and specialty isn't the computation itself, it's really easy to sort of leave these out and not ask about them because, I mean, it's not your thing. Next up. So I like to talk about planning versus writing a plan. So there's the good quote, plans are useless, planning is indispensable. So these days you'll get grants and they'll often ask you to make a data management plan. And I've seen other ideas like software management plan and well, how many different management plans can you add into your grant proposal or documents because you're asked to. But if you're doing something just for a grant, I think that's the wrong idea. So you don't want to make a plan for a grant. You want to make a plan for your research and then do the minimum amount of work to attach that to the grant. And really the way things like the structure which grants need, it's designed to look good to an outsider, but not necessarily be practical and useful for you right now. So whatever you do for your grants, have some sort of practical plan. Like people write down in your group's documentation, here's where you find their data, here's how we share your code, here's the tools we use, here's how we set up the environment, here's how you reuse this thing we've done before. This should be a designated part of onboarding new members and should be updated. So that way, when someone comes in, they at least know what's available within your group. They know your common ways of working and don't go inventing it over and over again. And I have yet to see a grant data management plan that's at that level of that's useful for that kind of purpose. Next up is the group documentation, or as maybe it's often called, the group wiki. So there should be a single place where you write down all the different things you're learning now and that you learn together. That helps with onboarding and keeping things useful over time. So probably many of you already know this and have already made one, but if not, this is a good starting point. And basically you start dumping all the most important information there, and then you start organizing it. So if you don't know what to do, find a wiki space from your organization's wiki areas, which hopefully it has, and use this to keep the operating information up to date. And whenever anyone tells you something, as a group leader, you can be asking, did you write this down in the group wiki? Okay, you're doing this, like you have this new data. Did you document it? Did you put it there? Can anyone else find it? Okay. Next is skills development. So this is something we've seen over and over again. Academic skills are not the same as the practical skills needed to do research. Even when academic skills include programming, doing software work is far more than just the programming. In fact, I might even argue that programming is the easiest, or how would I say it? Easiest, like least, the least difficult part of this. So the true interesting part is keeping all your stuff organized and used. So there's some things that you can recommend your groups to come attend. So this thing called Code Refinery, which incidentally is happening in 2 weeks from now, is a really good workshop that goes over all of the basic things. It's online, live streamed. I mean, it's all there. Consider taking your whole group to Code Refinery as a team, where basically you're working together on the exercise, or maybe even applying the exercises directly to your own stuff instead of doing the stuff that we propose. If you're doing lots of computing, we have another course, Introduction to Scientific Computing, which is pretty good. And set up ways to work together, learn things. Don't get into this situation where people are afraid to seem weak or like they don't know something and they don't want to ask each other. Asking each other is good. That's the way you learn things best. There's all these different strategies like pair programming and so on, which are useful, which, I mean, realistically, you probably don't have time to do. So my suggestions are everyone in your group should attend a Code Refinery workshop, or at least the first week of the Code Refinery workshop, or maybe even the first day of the Code Refinery workshop is enough to get some basic understanding of what version control is and how it works. And then after that point, make sure at least one member of your group at all times is sort of interested in this computational specialization and is willing to and has time to support others. This probably means, if you don't have someone already, taking it into account in your next hiring. But you basically want to get this community of people working together and learning things instead of using just what they've learned in courses. So just a reminder, why am I talking so much about teaching and mentoring rather than the interesting part, which we're about to get to? Because, and I can't emphasize this enough, you can't rely on academic courses to teach your group members everything they need to know. Once you get into the aspect of doing the actual programming, you'll have people who come in who might know programming, but they don't know how to do it well in a research context. And the same for data, the same for other types of computing. And if we don't work on these skills together, everything is, well, going to go badly. So let's talk about software in research. Software allows you to do a lot more than you can alone. So basically, instead of doing computations one by one, you write some software and then the computer can do it over and over and over again. I mean, that's obvious on the surface, but the way it transforms research, well, there's a reason why our teams support a significant fraction of the work at our university. So computing is everywhere. There's different types of software you might use. So you might use something which is developed by others. It might be sort of commercial off-the-shelf thing like statistical software, or it might be small things self-written that are as a byproduct of papers. Or you might be developing new software yourself internally. So this doesn't have to be big. It could even be just only the scripts which are running your analysis. And if you make something good, you might want to release it so others can use it. So here's a lightning overview of the different tools which you should be talking about to your users. And a lot of this is a summary of Code Refinery. And why is that? Well, because we've spent many years developing Code Refinery to cover everything which you need to know. So first is version control, and it tracks changes. So you go to Google Docs or whatever, and you can revert to an older version of something. Or Dropbox can take older versions of files. That's great, but it doesn't have enough structure for things like big amounts of code. It can't let you see individually what's happened and what's changed and revert back while keeping new changes and things like that. It also allows collaboration. So no longer do you have to go emailing things back and forth, which is basically the way stuff dies. It allows you to merge things back together. And maybe the most important thing is by using version control, there can be one single web repository that has all of the code, all of the data together. And that is a place that everything can rally around. And once you rally around that, then you're on the same page. So my suggestions, everyone needs to learn a little bit about some version control system. This is just a fact. So if anything I'm saying here sounds relevant to you, send them to Code Refinery, have them read some other online tutorial. It's just something you need to do. And then find this form of advanced support. And actually at the end, we'll talk about the support we have available at our university. And maybe you can find something similar at yours if you aren't here. So after you have version control, you might want a version control platform, which is basically the web interface for this. It can control the permissions, it can have issues, it can allow you to merge in changes from others, it can release your code, things like that. Yeah. So my basic suggestions here would be you should make at least one public GitHub or GitLab organization for your group, and that's where all your public stuff goes once it's ready for common use. Then also make one internal GitLab organization. So GitLab itself is an open source software package, which means that many universities have their own GitLab for people at their institution. You would basically set up one of these for your group, and that's for your internal development. And then you would strongly discourage personal repositories for the common code. So basically, don't have all of your group's work scattered around people's own computers and own GitHub or GitLab accounts, because once they leave, then that's gone. When you have the organization, though, you work together on it. Issue tracking. So once you have the GitHub or GitLab organization, don't let people just talk to each other about issues or say, oh, this thing is broken. Too bad, we're going to forget about it. But you can actually open it up and make an issue in there. This allows the people to communicate and not be lost, and things to be closed when it's done. Really, at this point, you get here once you get to multi-person projects and things which are somewhat important, which you might not get to for a while, or maybe it's not even relevant to every group. So after enough time, you'll get some sort of software, some sort of tool, whatever, which is actually pretty important to you. So maybe it's something which everyone in your group relies on. Say maybe the core analysis, which you've done before, and now everyone's using and making changes of. This needs to be protected pretty well and shouldn't be just broken anytime. So for that, we have something called change proposals. Well, GitHub calls it pull requests, and GitLab calls it merge requests, but basically it's a change proposal, which means that before someone can go modifying the common group project, people should make the proposal and it can be reviewed and then merged. So this is great when you work together. If you're not actually working together, people will make these pull requests and then sort of leave it and never get merged, and eventually all the group stuff dies, which is not good either. So decide which projects are important enough for this kind of formal, doesn't have to be formal, it could be semi-formal change process. And then make sure people do it. Make sure that the common thing is kept up to date. And for most of these things I'm saying, I don't expect you to necessarily do it yourself, but talk to your group and ask them, okay, do we need this? Does anyone want to set this up? It will be good for your career, and so on. Once you have some code that works, maybe you can ask your group, is it working correctly? Do you have tests for it? So software testing is this concept, well, automated software testing is the concept of writing tests which are actually included along with your thing, and then they can automatically verify functionality of stuff. And basically, it allows your code to become much more reliable, because anytime you make a change, you can automatically run all the tests and see that everything that people were doing before still works. And this is important once it gets big. So to be honest, not many things get big enough that this is really important, but well, it can happen. And it will happen to at least something in your group. Documentation. So after you have some sort of code or data, something like that, documentation makes it reusable. So the minimum here that I'd suggest is every project, which is basically every repository, gets a README file. And maybe as a supervisor, you won't be running and reading the code, but you can and maybe should read these README files. So the README files should say like who worked on this, how it works, how to test it, how to modify, who used it, citation, all of these kinds of things. If projects get larger, then you can make these like dedicated documentation sites. In fact, this material right here is part of a Sphinx site, in fact. So licensing, in particular, software and data licensing. So once I had a professor tell me this really interesting point. So if as a computational researcher, if I make some sort of method and I don't make it usable by other people, our impact will be minimal compared to what it could be otherwise. If people can't actually use your work, then they can't or don't want to cite it as much. And really, this is relevant to everything I've said before, talking about making your things reusable. Not everything, but just the things that are most important. And if you want something reusable, you need a license, preferably an open source license. So, well, this will depend on where you are, but in practice, you should talk among the stakeholders and decide of a license and get that applied as early as possible. maybe like at Aalto, you can decide on an open license yourself if you talk to all the stakeholders, as in the group leaders and the people that have done it. Otherwise, well, ask for the practices. And when you're reusing other things, try to make sure it's also openly licensed. Otherwise, you won't be able to improve it and reshare it later on if needed. Once something is good enough and you want to share it, there's well, you need to go to that point. So at least the minimum starting point is having this GitHub or GitLab organization where the code is open and available. That lets someone else see it, see the README you've written, clone it, and then use it themselves with the documentation you've made. If you need to go into another level, you can archive it on Zenodo, which is usable to make it citable. One other thing I'd sort of suggest is that when you're working, always assume that something will be opened in the future. It sort of, let's say, keeps you honest or something like that, and make sure that you're using best practices. And that someday when your thing does actually become useful, you can open it pretty well and quickly. So we could have a discussion now, but based on the way this is going, I propose we have the discussion at the end after the video is done. But we'll have a discussion of what can go wrong when people work together. So other relevant topics we need to talk about here. There is data storage. So how does your group store data? So most important, you should discourage single user storage spaces for primary data, whether that's laptop or home directories, things like that. Have some sort of common space. Because if the data storage is common, that means work can be common. Otherwise, I hardly see any way to get there. At Aalto University, we have lots of network drives, which is really good for the sort of really large, backed up, secure, and shareable storage space. And that's basically where most people do most of their work. My suggestions, well, have a plan and talk to people about it. Request a central network drive storage as soon as possible, or have some sort of alternative, whether it's a single Google Drive location you're sharing or whatever. Make sure it's not dependent on only one person. And actually talk about where the data is, like during each of your meetings for new data or whatever. You know, it should be okay to ask your group members, where is your data stored? Is it documented? If you won the lottery and quit tomorrow, would anyone be able to find this data and use it? So at Aalto University, what are our options? Well, of course, there's always the own devices, and these have very limited backups. Also, I mean, even though personal devices are encrypted and are allowed for confidential data, I would always consider them less secure than the centralized devices. The Aalto home directories are a common thing, especially for computational kind of people. We have pretty good network drive availability at Aalto University, especially in the computational schools and departments. These are large, backed up, and you can basically put whatever you need there and access them on your own computers. Things like the high-performance computing clusters. These have extremely large storage spaces, direct cluster access, and are not backed up. So it's good for very large data, but make sure you have another copy somewhere else. If you're in Finland, CSC has a lot of other data storage locations. And of course, if you're practicing open science well, eventually your data will become open, and then you can use public repositories. There's a wide range of different types of computing devices you can use, anywhere from small on your own devices to remote servers to very large computing clusters. This is sort of, well, we can talk about this more later. I think there's not a point in making a longer list here. So if there's one thing I can emphasize most, it is that you shouldn't go in this alone. If you're in the target audience of this talk, there's just so many things for a computational researcher to know that I don't think that any one person can know everything. So take your support along with you. At Aalto University, we have the data agents and research software engineers. Data agents can consult with anything about data. Research software engineers can consult about the practical side of anything from computing to software to data. And we're here. So at Aalto, we have this thing called the Daily Scientific Computing Garage. And it's basically every weekday on Zoom, we're available and people can drop by and ask us questions about anything we've talked about in this talk and more. We can help you find the next level of whatever it is you need. If you really are a new group leader and you're at Aalto University, come by and ask a consultation from us, and we can sort of chat about what you do and point you to the best possible resources. Make sure your group members know to ask us when they have questions also. So here's my overall summary, what you should do and what you shouldn't do. Although this is focused, this is phrased from the negative. So you're not allowed to not use version control at all. So you need to learn a little bit of this, even if it's used on just your own computer. You're not allowed to push to some online repository to get a backup and make things shareable. You're not allowed to have critical data or material only on your computer. You're not allowed to make something so chaotic and disorganized that when you come back in a few months, when you said you would, you just can't make sense of it. You need to keep it organized as you're going. And you're not allowed to be alone. But on the other hand, I really think it should be emphasized, you don't have to do everything perfectly. Like, not every project you do is going to be a perfect project and be used by tens or hundreds or thousands of other people. Many things you do will be small, and you need good enough practices there, not best practices. And you don't have to know everything yourself. So here's a checklist which you can read yourself about some of the most important things from above, mainly focused on these GitHub, GitLab organizations and the management plans. And with that, we are done. So if you are doing the programming yourself, there is this Zen of scientific computing, which is written with, which is written from the individual researcher point of view, doing a single project. And it says for each project, what are the level of steps which you need to update and improve? And like, where do you start and where do you end for each project? So with that said, let's see if there's any questions by the chat. So I'd suggest that people can either ask questions or give some comments. Like, does anyone have comments about things that have especially gone wrong? I like disaster stories. Maybe we can talk about some of these and then see what can be improved. And let's give a few minutes for the questions to come in.